Hi everybody, Mr. Judson here. So our entry-level task for today is really just a question about the two formulas that we learned last time we met on Tuesday. In a geometric sequence, how do you find the nth term and the sum of the first n terms? Just want you to write down those two formulas. Try and do it without looking back in your notes. If you have to look, that's okay, but really this is just about seeing if we remember. All right, so our two formulas. First of all, the nth term is going to be the first term, which is a sub 1 times r raised to the n minus 1. Remember, this is when we're multiplying to get to the next term, and r is the number that we're multiplying by. The sum of the first n terms is going to equal the first term, a sub 1, times 1 minus r raised to the nth power over 1 minus r. And that would give us the sum of the first n terms. Just in case you were wondering, could we cancel something here and make this formula a little bit easier? Well, the answer is no. If we could do that, then we would have. But you could not cancel anything here. It wouldn't work. Maybe if this was r squared, we could factor this and then cancel something. But because the n value changes, we really can't do that. Okay? So there's the two formulas that we worked with on Tuesday. We're gonna go ahead and just take these and push these ideas just a little bit farther for today. So not really new material, but just pushing the idea a little bit farther. So just to make sure we understand some terms, this is something we looked at last time we met. We have a sequence here. What I'm doing is I'm multiplying by 1/2 each time to get to the next one. And one of the things that I've done is I've used this word sequence, but sometimes you also use the word series. And this right here is a sequence. A sequence is just a list of numbers. The moment you say, let's add those numbers, 4 plus 2 plus 1 plus 1/2, and we're just going to keep on going, now it's a series. So a series is a bunch of numbers that are being added together. A sequence is just a list of numbers. So as we use these words, we want to make sure we keep those two definitions straight. So here's an interesting idea. Again, we looked at this last time we met. 4, 2, 1, 1/2, and this is going to keep on going forever. What if I said to you guys, I want you to add up all of these numbers and just keep on going forever? There is no end. Well, most of us would sit there and say, well, that's dumb. The answer is infinity. Of course, if we're going to keep on adding more and more numbers forever, the answer has to be infinity. Or does it? So one of the things we want to look at today is if the r value is less than 1. So greater than 0 but less than 1. We don't want to multiply by negative numbers. I suppose we could, but we're not going to do that. If the r value that we're multiplying by is less than 1, which it is in this sequence, we're multiplying by 1/2, then the sum is going to equal a sub 1 divided by 1 minus r. And if you think back to this from last time we met, if I add these, 4 plus 2, that's 6, plus 1, that's 7. Add a half, you get 7.5. Add a fourth, you get 7.75. Add an eighth, you get 7 point something. It appears that this is getting close to 8. And so if we take this new formula here and use that, we would say that the sum is going to equal the first term, which is 4, divided by 1 minus r. Well, the number we're multiplying by is 1/2. So that equals 4 over 1 minus 1/2 is 1/2. If I flip that over and multiply, I get 4 times 2, which is 8. So if I was to continue to add these numbers forever, no, I would not get infinity. I would just get closer and closer to 8. And I think I remember that from our last video. All right, so here's one for you guys to try. Remember, we have a new formula here. This is an infinite sum. We're going to add numbers forever. The only key is that the number we're multiplying by has to be less than 1. If that doesn't happen, this doesn't work. So you guys want to figure out what the r value is, and then figure out what this series would add up to. Go ahead and try that. All right, so to get the r value, I could look at the first two terms and just say 5 times what number equals 3. And if I divide by 5, I would get r equals 3/5. So our r value is less than 1, so this should work. So that means that the sum should equal the first term, which is 5, divided by 1 minus our r value, which is 3/5. That would equal 5 divided by, this would be 5/5 minus 3/5, that's 2/5. And so if I flip that over and multiply, I would get 5 times 5/2, which would be 25/2, or we could say 12.5. If I kept on multiplying by 3/5 to get the next term, so what would that be? 27 over 25. And then I do that again, and I do that forever and add all those numbers up. That's what I should get. All right, so here's another one for you guys to try. We want to add up this infinite series. I know I've said this a lot. Some of you might think, oh, Judson, why are you going so fast? I'm trying to save memory. Remember, you guys can hit your pause button and try these problems. I'm only going to wait 5 seconds, and then I'll go ahead and work the problem out. So again, I need to figure out what the r value is. So I'll just take the first two terms. You don't have to take the first two. You can take any two terms. I could say 8/3 times r equals 16/9. It just makes sense to pick the two easiest ones. So I'll do that. 6 times r has to equal 4. So if I move that 6 over and divide, I get 4/6, which reduces down to 2/3. That's what we're multiplying by. So that means that my sum is going to equal the first term, which is 6, over 1 minus 2/3. That's going to be 6 divided by 1/3. When I flip that over and multiply, I get 6 times 3, which is 18. There's my answer. All right, so here's another problem. We've seen this before. This says that the summation for n equals 0 to 40 of 5 times 3/5 to the n power. You can already imagine what some of you are saying right now. Oh no, I am not doing that, Mr. Judson. Maybe not in those exact words. But yeah, we're going to first let n equal 1, plug it in, then 2, then 3, then 4, 5, and so on, all the way up to 40. That's a lot of things to write down. And so what we need to do is we need to figure out a better way to do this. Well, if I just write down the first couple terms, I've got 5 times 3/5 to the 0 power, so that's really going to become just 5, plus then I've got 5 times 3/5 to the 1 power, so I guess 5 times 3/5, the 5s would cancel and I'd get 3, plus then I've got 5 times 3/5 to the second power. So that would be 9/25 times 5. 5 and the 25, I could cancel there and get 1 and a 5, so I'd have 9 over 5. And then this is just going to keep on going. Well, the nice thing here is I can see what I'm multiplying by. I multiplied by 3/5 to get the next term, and then I multiplied by 3/5 again, and so we're going to say that our R value is 3/5. So if this would have said the summation for n equals 0 to infinity, well then I can just go back and do it like the last term, or the last problem I mean. But it didn't say that, it only said up to 40. So now I have to think to myself, okay, what was that formula for the sum again? We just wrote it in our entry task. We said the sum equals a sub 1 times 1 minus r raised to the nth power over 1 minus r. And our n value, oh boy, we got to be a little careful here. I want to say the n value is 40, but I didn't start at 1, right? I got to think a little bit here. I started at 0, so my first term was when n equals 0. My second term is when n equals 1. My third term is when n equals 2. So by the time I get up to where n equals 40, I'm on my 41st term. So that means right here, I want that n value to be 41. I know what I'm multiplying by. R is 3/5. I know what my first term is. It's 5. So now we could say that the sum is equal to the first term, which is 5, times the fraction 1 minus 3/5. And that fraction has to be raised to the 41st power over 1 minus 3/5. So now what I'll do is I'll go to my calculator. I'm going to do 1 minus 3/5 raised to the 41st power. So 1 minus, in parentheses, 3 divided by 5, and raise that to the 41st power. What I got is 0.999999999. It's 1. And now I'm going to divide that by 1 minus 3/5, that's 2/5. So divided by 2, let's see, I should put this in parentheses, 2 divided by 5. So now I've got 2.499999999, which sounds like 2.5. And then I'm going to multiply that times 5. And so what I got for an answer here is 12.49999999, a whole bunch of 9s, which I'm just going to say that's really about 12.5. So I have a feeling if this would have gone on to infinity, yes, I would have gotten 12.5. Since I only went 41 terms in, I guess that means I'm getting really close to 12.5. All right, so here's a problem that is similar to the last one. You guys go ahead and try this one. See what you can come up with. All right, so I'll just start by saying if I plug in a 0, anything to the 0 power is 1 times 10, that's 10. And then I'm going to let n equal 1. So if I put a 1 in there, I've got 1/5. 1/5 times 10, that would be 10/5, which is 2. And then if I plug in a 2, I would have 1/5 squared, that's 1/25. Times 10, that would be 10/25. And that reduces down to 2/5. And I don't even really think I had to do this. I could already see right here that this is what I'm multiplying by. This is my R value. I kind of need to know what I start with. So when I plug in a 0, I got 10. 10 times 1/5, that would be 10 over 5, which is 2. 2 times 1/5, that would be 2 over 5, which is what we have there. So at this point, I could just say that the sum is the first term, which is 10, times 1 minus the R value, which is 1/5. That fraction raised to the, so we've got the same situation again. We're starting at 0, not at 1. So this is really 21 terms. So I want to raise this to the 21st power over 1 minus 1/5. If that 21 doesn't make sense to you, write it out. Start at 0 and go 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 21, and then count how many terms you're going to have. I'm sorry, all the way up to 20, and then count the number of terms that you have. All right, so now I'm going to go to the calculator. So I've got 1 minus 1/5 raised to the 21st power. I know 1/5 is the same as 0.2, so I'm going to go 1 minus 0.2 raised to the 21st power. And I got 1. 1 minus 1/5, that's going to be 4/5. So I now want to divide by 4/5. So divided by, in parentheses, 4 divided by 5. I now have 1.25 times 10. And I got 12.5 for an answer. I think that's just a coincidence that we got the same answer as we did on the last problem. But there it is. All right, so I've tried to zoom in on the calculator, and hopefully you guys can see this. But I wanted to show you something. We can actually do this problem on our graphing calculator. If you hit the math button, and then you arrow down all the way to option 0, see that summation with the summation symbol? If we hit enter for that, look at that. I could actually do this problem in the calculator. So we could check this to see if we're doing things right. So rather than n, I'm just going to use x because I've got a button here for x. It makes it a little bit easier. So I'm going to do the summation for x equals 0 to 20. And inside the parentheses here, I'm going to do 10 times, I'll do 1/5 inside parentheses, so 1 divided by 5. And then I'm going to raise that to the x power. So I've got the summation for x equals 0 to 20 of 10 times 1/5 raised to the x. And again, I'm just using x instead of n because I've got a button for that. And so I hit enter. There it is, 12.5. That's what we got. So that's something you guys can use as a way to check your work and see if things are turning out okay. You might even want to hit pause and go back and try the last problem that we did. All right, so that's it. That's what we have for today. So here's our next assignment, number C4, page 670. We're going to do 53 to 71, just the odds, and then 79 to 85, just the odds. All right, you guys stay safe. I'll see you next week.